So with that, I will hand it over to Peter Larson, who knows Peter much better than I do, to introduce our speaker. So.
Well, I wouldn't exactly say that, but very short and sweet. I got introduced to Petr Viktorin. I don't know if I just butchered your name, sorry. um, Through some contacts at Red Hat as someone who actually is very, very deep and a very active contributor on the Python side, who would be a great speaker and who would be a little bit. I've had a chance to actually see what Peter has done on both the open source perspective and what they've done for Red Hat. We have a true expert here on our hand. So without further ado, from across the ocean or all the way in the Czech Republic, we have our guest speaker today, Petr Viktorin, and he's going to talk about Python and getting started. So take it away, Peter. Thanks for coming.
Right, hello, everybody. So as the other Peter said, I was asked to give an introduction to Python to a lot of people I don't really know. So it's nice to meet you all. I hope my information about you is correct, that most of you don't really know too much about Python, but there are some of you who already do something with it and would like some advanced information. Is that sort of correct?
I would say you have everything from very new beginners to, I would say, rather experienced people and everything in between here, but I think you have a majority of people who want to get a better introduction to Python.
Righty, so I'll start with the basics. Python is a programming language. It was, let's see, on Wikipedia says it first appeared some 30 years ago, so it's pretty old. It's actually older than Java, for example. And it was originally developed by one person, Guido van Rossum, and then as open source project go, other people started contributing, and a while ago Guido stepped back as like the main leader of the project, and now it's run by a council of 5 people who put in or who say what's or have the final say about what gets into the language. Python is an interpreted programming language. You might say it's a scripting language, a bit like, let's say, JavaScript or Bash. So it's not compiled as C or Fortran would be. You can just write the code and execute it. If you want to install Python, if you actually have a Linux box, you probably have it installed, because on a lot of the systems, some of the system infrastructure is written in Python. So you can just write Python in your console and get the Python prompt, which is these three less than signs. What you want to check when you're running Python is the version. There's Python 3, 3.8, or 3.8 is the latest stable version. There is also Python 2, which is about 10 years old, but it's been supported for those 10 years by the development community and is just now being abandoned, so everybody should move out. But not all of the distributions have done so already. So if the Python command gives you Python 2, then you should run Python 3, and hopefully you will get this prompt. If not, then install it using your package manager. So for Fedora, it would be dnf install Python 3, and that will give you the interpreter. The same would go for Python 2. If you're on Debian or Ubuntu, instead of DNF, you would do apt-get, I think. So the same way you install anything else, should be able to install Python. So how does this work? The easiest way to use Python is just to use it as a calculator. It knows all the usual operations with numbers. It has parentheses, everything you'd expect. I actually have a shortcut bound to a terminal with Python, so if I want to calculate something, that's the way I do it. What's interesting, if you do this interactive mode, which means you have this prompt and it asks you for a Python command, is the variable named underscore is always bound to the last result. So you can do some like you would do with a calculator, use the last result in a computation. Right? So this only works in the interactive mode. If you're writing a bigger program, this doesn't work because you don't have the individual commands. But if you're using it as a calculator, that can make it a bit nicer. The other nice thing about Python is a function called help. This is a function. You call it by writing the name of the function and some parentheses, and then you write some Python object that you want help on. For example, I picked the function abs, which will return the absolute value of the argument. So this means that if I call the absolute value of minus 6.9, it'll give me that. There's a bunch of other basic functions that yes, you can easily Google or otherwise search on the internet for. Right. By the way, if you have any questions, please ask. Since this is not an in-person meeting, I don't really have feedback from you. Also, all the cameras are turned off. So if I'm going too fast or too slow, please feel free to say something. If not, well...
Just do question in chat if you don't want to interrupt, and I'll let you know.
All right. Yeah, I do have the chat here, but I have too much information around. So if you say that out loud, it'll be great. As a programming language, Python has a few data types, which are integers, floating point numbers, strings, booleans, true and false, and a whole lot of others, but these are like the basic ones. Unlike languages like JavaScript, Python is strongly typed, so you can, for example, add together numbers of any kind, but you can't add a number to a string. Right? If you want to do something like that, you would need to convert the number to a string or vice versa. And you can see the plus operator can either add numbers or it can concatenate two containers or two strings or other lists of stuff. With the true and false, those usually come up if you compare stuff. So I can do 12 is less than 9, gives me true. I don't know. I don't know if you're familiar with any languages that do less than or equal in this way, greater than or equal in that way. I think it's pretty standard in modern languages, but well, that's how you do it. This kind of stands for not equal. Once you have that, once you have comparisons, it's nice to do conditional statements. So in Python, if you want to do an if statement, you can compare like that, and anytime you have a block of statements, so this if would execute a block of statements, a set of statements, only if this condition happens to be true. So anytime you have that, you have to indent your code. And let's say now I want to print yes, otherwise I print no. Right? So here's an if statement, and if this condition happens to be true, this block of code gets executed. Otherwise, this block of code gets executed. I hope nobody's having any trouble following that. If it's not true, let me know. This kind of stuff is not really easy to do in the interactive console, because you only have the standard read line, as you know from Bash, for example. So you can go back individual lines. So if I want to go back to this 4 statement block, I would have to use my up and down arrows for each statement and then write enter. It's not that easy. So whenever your program gets complicated enough, you have 2 options. Either you can get your text editor and write in there. Let's see. Copy it over line by line. Other editors might do it easier. I save this somewhere.
Are there any rules for how much you have to do?
Any tools for what?
How long of an indentation? Is it a space? Is it a tab?
Yes. I'll get to that shortly. Okay. So if I write this in the file, I can run Python with the name of the file, and it runs from top to bottom. Right, the same thing you would do with a bash script, for example. Now, as for the indentation, that's there because you might have more items or more commands in the block. You can even nest them. Like that. So this would... that. If I put a 3 here, it'll skip this if, because this doesn't matter anymore, right? So in a lot of other languages, you would have braces like this. I don't know if anybody's familiar with that, or if everybody's familiar with languages like C or Java, JavaScript. In other languages, you would have begin and end, for example. Python will just give you these colons and then the indentation, which is a bit weird if you see it for the first time. But I do a lot of coding in C as well, and I know that even if I have the braces, I have to align the code nicely anyway, because otherwise it's unreadable. So this is one of the ways Python tries to make it hard to write unreadable code, right? Because you always have to indent it properly, otherwise it won't even compile. Now, as to the number of spaces you should put here, you can put any number of spaces you want. It can be, I have 7 here, 1 here. The program does exactly the same. If I would have tab characters here, it would also work. I can't mix tab and spaces, but I, for example, could have this as a tab, and that would work exactly the same. As a convention, we use 4 spaces. So that's basically what most of the Python programmers around the world have decided on. You just use 4 spaces, and then your code is compatible with everybody else's. If you have some kind of special need, you can use anything else, but for most of us, spaces it is. My editor is configured so that I can't even put a tab in my files or in my Python files. So that's, I guess, the weirdest thing about the language, this significant white space, this indentation. And you can always see that a block, like an indented block, is coming because there's a colon at the end of the line. This helps, for example, editors. If you use any kind of advanced editor, it'll indent the line for you. Right? So that's one option, getting back to what to do with these multi-line commands. One option is to put your work in a file, which of course lets the program persist if you want to use it after you turn off the interactive prompt. You should save it in a file. The other thing you can do is install a program called IPython. I think on Fedora it would be Python 3 IPython. So this is a system package. I hope that's it. I don't actually know what the package name is on Debian, but hopefully it should be similar. And then I can run the IPython command, which is a bit more advanced, but it's also an interactive prompt. And this one lets me do multi-line blocks and then edit them in a sane way. So one arrow up will give me the last block, another arrow up will let me move in there, and if I'm on the first line, it does the history again. So if you do any kind of interactive work, I recommend using this this advanced shell, let's say. Right. Any questions so far?
There is one question in the chat asking if you could go into detail on Python with regards to interpreted versus compiled.
Oh, definitely. I can go into detail. Let me save this question for later, because I would like to tell you something about variables first, and then I can dive into all the detail you need. Right?
Give me a shout if you need a reminder of the question.
All right. It should be variables importing, and then I'll go into this. Right. So variables. I hope everybody here is familiar with some concept of variables. That concept will probably be wrong unless you did stuff with Python or JavaScript or other scripting languages like that. So in Python, you create a variable by assigning something to a name. So for example, I can say x equals 12, and then whenever I say x in the rest of the program, that name will correspond to this value here. All right, so I should still do the same thing. If I do a higher number, it should go into the else block. Right, so there's no declaration, there's no like type you should give the variable, there's no even let. You just assign to a variable and that makes it appear. you can assign any type to a variable. So if I do this, x is now a string, and when I compare a string to a number, I get a runtime error. So if you're used to compiled languages, this will happen a lot to you. For a lot of the errors, you get a runtime error when something is wrong. This kind of sets the niche for the Python language. It's nice for prototyping stuff, for the part of the process where you don't really know what you're going to program. You're experimenting with what you can do and how the program should work. And I find that Python is really optimized for this use case, to make it easy to put your ideas down quickly, make them work, and make them work correctly, which means that if something is wrong, you get a hard error. Right? If I mix up my types, Python doesn't try to guess, what's the numerical value of ABC so I can compare it to the 12. It'll just say, something's wrong, please fix your program, which means, I have to think about this case, but the program doesn't do the wrong thing. It gives me an exception like this. I also find that the error messages that Python gives you are pretty nice. If you compare it to, say, JavaScript, I really like the fact that it gives you the contents of the line that failed, so you can quickly see, for example, if you make a typo, I can see, here is the thing that probably is wrong. I get a name error, this name is not defined. There are languages that have better error messages, but for its age, Python is pretty good at this. So that's a bit about variables. If you have any questions about them, let's not bash other languages, they all have their uses. But yeah, I try to not be a fanboy when I explain stuff to people. The question is, JavaScript has error messages and snark. Yes, JavaScript has error messages. I think Python's a bit better. Yeah. About variables. Oh, this is a nice question. So I'll copy the question so everybody can see it. If you don't set the type when you declare them, how do you know what type there are? This is actually something interesting about Python's variables. Let's leave it in. Let's comment it. This is a comment, by the way. So the interesting thing about Python variables, when you compare them to C variables, for example, that the variables are just names. They're names for values. And it's the values that have the type. Right? So anything can go into this X. Any Python object can be named X. And if I put a value that's a string in there, then X refers to a string. If I put a value that's an integer, then X will refer to that integer. So variables don't have types. The values have types. Thanks for the question. So to try and go towards answering the interpreted versus compiled, let me do one thing. Skip ahead with some of the basic stuff, and I'll show you importing. So one thing you can do in Python is if you want something extra, then you can import it. For example, I can use the function abs, absolute value, right away. That's built into Python. When you start Python, the absolute value function is there for you. there are lots and lots of other functions that are not built in. For example, if I want to take the sign of some number, then I get an error, sign is not defined yet. What I need to do in this case is import it, which means I say that from the module math, I import the function sign. So this is some kind of module that is stored somewhere on your computer where Python can access it. It's part of Python's standard library, so it should always be there. And from this module, which is a collection of functions and other stuff, I can import this particular function, and that makes it available to my code. So this is the sign of minus 67 radians. If you want other functions, just search the internet for whatever you need. Sometimes they're part of the standard library, like this one. I didn't have to install anything extra. Sometimes you have to install them from a library, either from your package manager or from the community repository. We'll get to that later. Now, what the import does, which might be interesting, is it sets the variable named SIN. So functions are first-class objects in Python. I can print the value of this variable. It tells me that's a built-in function called assign. I can set a variable to this, and then I've made an alias. It's the same thing as before, right? So all this does is it sets a variable, and now the variable sign is a function. The same way as I set a variable to a string. Right? The variables are just names. Hope that makes sense. Let's see if there are any questions. Variable annotations. I will put that into my notes, but I won't I won't cover that just now. And there's a note that you can turn on captions, and I don't know how they're working with my accent, but hopefully they're fine. Right, so what I wanted to do is to show you how to create these modules yourself. The way you do that is you create a new file. I'll name this file, for example, test module.py. I'll put it in the same directory. Now this is just a comment saying what the file name is, and here I'll set some variable. Var equals 1, 2, 3, and then in my other file I can do from the name of this module import my variable. I can print it, and there it is. Right? So to create a module, you just make a file, stick it in the right place. If it's just a simple script, you can stick it in the current directory. Otherwise, you have to somehow package it so you can distribute it to people or distribute it to different machines. I don't think we'll get to that, but the important thing is modules are just Python files. So when I do this import, Python goes, executes all of this module, and lets all the global variables here be available for importing like that. Now, let's see, there's a nice question here. Is there a default location for scripts like demo.py? So the thing I'm doing here is demo.py is in my current directory, and when I run it as python3 demo.py, this is actually the file name, the normal file name I use. So if I don't put in the path, it comes from my current directory. if I wanted to make this a command, I could put it in my bin directory, and then I could use it without the Python 3. Right? For example, if I look at user bin DNF, which is the package manager in Fedora, I see that is actually a Python script. It has a shebang here. So if I type in DNF at in the shell, this is the script that will run with Python. So if you wanted to make it a command, make it executable, and put it on your path. If you want to make it importable, like this one, then there's something like the executable path from Linux, which is available if I import sys, and it's available at sys.path. And here are all my directories that I can import modules from. The empty one is the current directory, and most of my stuff would be in this one. It's userlib, Python, and the version. And then there's side packages for stuff that I install with the package manager. So I guess it's not this one, but this one. That's where most of the stuff lives, and if you install it system-wide. I hope that answers the question, Roger. So now I can get back to the question, if I can go into detail on Python with regards to interpreted versus compiled. So for the people who don't have an idea what this is, stop me if you all know that, but an interpreted language would usually mean that when the program is executed, then it's taken line by line. So for example, bash is interpreted, so it would read a line from the program, execute it, read another line, execute that, read another line, execute that, and go like from the top to the bottom. Compiled means that the language is first converted to usually native code, so something the processor on the computer can process. So the whole program would be taken, converted to some machine code, and then you would run that. Python and JavaScript and Java and Ruby and programs like that are something between those two hard categories. So what happens in Python is the whole thing gets compiled, but not to machine code, but to something called bytecode. So what happens here if I make a syntax error, for example, somewhere here, then I get an invalid syntax error. Because what happens is Python looks at the whole program and tries to make sense of it, tries to compile it, tries to break it up into statements and expressions. And here it doesn't have a clue what this line means, so this whole program is invalid. So that's a syntax error. That's a compilation error. If you have a syntax error, you can't run the program at all. Other stuff, like if I would have a division by 0 here, the whole program gets compiled, and since this is technically a valid statement, this would only result in a runtime error. So you can see I get all the stuff that happens before, and then I get the runtime error. Right? So you can say Python is compiled. and how it is compiled. That's an interesting thing. So when you run a script like this, then Python will go and compile the file and run it. When you import something, the same thing happens. Also, Python will compile the file you're importing. And the other thing that happens when you import stuff is that Python makes a cache. So usually the files you import don't change that fast. So it caches the result of the compilation. And if I look into my directory here, I see that Python made a directory called __ pycache __, a special directory with caches. And if I look into that, there's a test module for Python 3.8 with a PYC, which stands for Python cached, and the bytecode for this module is stored in there. So next time I import it, assuming I didn't make any changes to the file, Python just uses this instead of compiling the whole module again. That can be pretty useful if you have a lot of complex modules. Not for this one, probably. Does that answer the question? Well, hopefully.
Hey, Peter.
Hello.
Hey, speaking of PYC files, can you explain why sometimes they end up underneath the PyCache directory, and sometimes they just dump it in the directory right next to your code?
That's a good question. So if I would run it under Python 2, that would dump it in the current directory. So that's the old behavior, the 10-year-old behavior that is really not very nice, because what happens now is if I remove this py file, this source code, the cache still remains there, and my variable is imported from the cache, even though I removed the actual module. And this tripped up a lot of people almost every time they were starting to create their own modules. Like you remove your code and it's still there for some reason. So the reason this the PyCache directory was introduced is to stop this behavior. Right? Because in Python 3, if the py file is removed, then it doesn't even look in the PyCache. It's still looks at the PYC file. In this case, it's a PYC file for Python version 2, so you get an error, can't import that. So let's remove that as well. But if I only have the cache, I have removed this, the original source, then my program now won't work. Does that make sense?
Yeah, perfect sense. I have to admit, I can't swear to it. I thought it still did it in 3 occasionally too, but
Nope.
I definitely saw less of it. I just was curious where that came from.
So what can happen if you run Python 2 accidentally? It'll put PYC files all over your disk. But Python 3 does the PyCache stuff. What you can do is if you take this PYC file and move it to the name of the module .pyc in the current directory, then you can remove your original module, and then it will actually try to import this PYC. So that's there to appease the people who want closed source stuff, so they don't have to distribute their Python code. They just give you the PYC for a particular version, and that will work as well. But you definitely have to do that on purpose.
Thanks, Peter.
No problem. So let's save this again. Thanks for all the questions. Those are pretty nice. So let's see. There's a question on how does the cache determine if there was a change to the file. Right. So that's important. And look what's actually in the file. So I guess it's not very visible here. So if you actually look at the hex dump of this file, there's a magic number which says this is a Python cache file. There are some flags. There is the timestamp of the file. So if you edit it as a human, you don't edit it multiple times each second, that will invalidate the cache. And there is also the file size. So if that changes, the cache will be invalidated as well. It works very, very well in practice. And both of these things are something you can get from the inode of the file, so it's quite fast to check for the cache invalidation. Another question is about pip, which I'll get to later. Thanks for all the questions. Nice sidetracking. Let me do one more thing. Actually, several more things. So just quickly to go through the basic stuff. Python has strings which are put in either single or double quotes, doesn't matter which one. Sometimes it's nice to be able to use different ones because you have the other quote inside the string. You can add strings together. We've seen that already. Strings are first-class objects, so you can, for example, call methods on them. So here's an object, and you do dot upper, and it gives you a new string with all the letters uppercased. Python strings are Unicode, so if you are from a country like mine, which has lots of these funny characters, it does the right thing. If you think English doesn't have these, then you're being naive. Especially if you do stuff nowadays with all those emojis and stuff like that. Right, so Unicode works just perfectly, especially on Linux. If you try to do this on other operating systems, you might have trouble with the default encoding when saving to files, but all the funny emojis work very nicely in Python 3. Speaking of emojis, Python has backslash escape sequences. You might be familiar with those from, for example, C. And if I print the string out, the backslash n means a new line. So what happened here is that Python showed me the string as it would show to me for a programmer, right? So in quotes and with the escape sequence, so I know this is a string. If I say print, it prints it out nicely for users, for example. So then I get the new line. There's a bunch of other escape sequences. The one I like most is capital N, which lets you put in the Unicode name of the character and just put it right there. Did you know there was a snowman in Unicode? One of the nicest things about strings in Python is slicing. So if you have a string, you can get a particular character, add a particular index in the string. It's 0 indexed. So here's the second one, third one. If you put in a negative index, it goes from the end. So -1, -2, you can see can get the last thing of a string very easily. Another thing you can do is take ranges. So if I want everything from this E here up to but not including this D here, I would say 1, which is the starting character, then a colon, and then whatever I want as the ending character. Right? I can also omit one of these numbers, so I can do everything from the start to character number 5 and get hello. I don't know if I'm going too fast for somebody. This would give me everything from the start to character number 5. So up to but not including number 5. If I want the rest, I would start at number 5 and go on from there to the end. So quite easy. This one is used a lot. If you do some kind of low-level stuff with Python, it does have something called byte strings. These are not Unicode, so you can't put in weird characters. So these are bytes as you would save them in a file or send them across the internet. If you have a Unicode string and you want to make a bytecode from it, you would encode it using an encoding like UTF-8, for example. So that would be what actually goes into the file when you save this this weird string. So, question check. Something about decorators and annotations. All right. Let's do one more thing here, and then I'll get to functions, okay? So we've done a bit on numbers and strings. The other another data type that Python has, which is really powerful, is lists. If I put a bunch of stuff in square brackets, I create a list. Let's call it L, and then I can take numbers or can take items from it the same way I can do it with strings. I can add multiple lists together, which creates a new thing, a new list. I can also use the for loop to do something for every element of that list. So that's the main syntax for loops in Python. I have something which has a bunch of items in it, like a list or another sequence, and I say for each element in that sequence, do this indented block of statements. Python also has a while loop, but that's not really used all that much compared to other languages. Usually you would iterate over something with a for loop like this, right? So you have a sequence, have a collection of items, and you loop over that. Now, I said before that the variables in Python don't have types. Also, the lists don't have element types, so I can do a mixed list, which would be L plus A, B, C. And there's no problem with putting different stuff in a list. Usually you wouldn't do that because it's kind of hard to work with this, but nothing's preventing you from doing that. Lists are also mutable in Python, which means you can change them. There's a bunch of methods like append that don't give you a return value, but as a side effect of their execution will modify the list. And thank you for this question. The question is now, what do you find the most common beginner issues with Python? So one of the things I do is I teach Python to beginners. There's a free beginners course that I kind of maintain, and I teach it to test if the materials are okay and people get it. So I find that one of the most common issues once you get to lists is this mutability. So if you have one list and then you can change it, right? The most mind-boggling thing about this happens when you have multiple names for the same list. So what happens here is I have a list called L and a list called another, and when I append let's say a 6 to L, then I have changed the list, which means whatever name I call it, it's been changed. Now this is very weird to people who come from languages like C, for example. So it's nice to visualize this graphically. So what happens? Yes, pointers and references. That's how you do it. So what happens here is I know L is my list. So there's an object somewhere that has 1, 2, 3, 4, 5 in it, and this list is labeled L. So L is some kind of label or name that's attached to this, and there's another which is also some kind of label that's attached to this list. And no matter which name you use to access this one single list object, that's the one you'll get, and of course the other name refers to the same object. So everything in Python you can think of as a reference, as a pointer to some value. If you're familiar with some of the more advanced C techniques, you can think of all these values as variants, as tagged unions, let's say. So each Python object, each Python value has its type stored with the object, and then you can to any variable you can assign any of these Python objects. The other most common beginner issue in Python I find are local variables, which I would like to get to once we see functions. Let me just answer this one. What is the leading Python unit test framework? That would be PyTest. So this is the name. It's a third-party library. You have to install it. It doesn't come in Python, but that's the one that's most used right now. There is also unit test, which is built into Python, part of the standard library, but it's a bit more cumbersome to use. And sometimes you might see nose, which is deprecated. The authors are not working on it anymore. So if you see that, get away. Right. Let's see. If I have a list, I can. So usually, if I can name some object, I can also delete it. So this would this DL statement takes some value and tries to get rid of it. So this would delete this 5 here from the list. The question is, how do you copy the data? So usually I would convert the list to a list. There's a bunch of functions that convert data types. For example, str makes a string out of its argument. So these are now the characters, brace, for, comma, and so on. There's int, which takes whatever and makes an integer out of it. And there's list, which takes some kind of sequence and makes a list out of it. If you treat strings as a sequence, you'll get the list or the individual characters. And when you create a list out of an existing list, then you get a copy of that list. So that's how you can do it. There is also a method called copy that gives you a copy of the list. So I hope that answers the question. I prefer the list because you can always be sure of the return value here. If with a copy, if you're starting with something else than a list, then you'll get that data type back if it has the method. So that's a bit for lists. And now I think it's about time to get to functions. So functions will again have multiple statements in them. So let me put them in the file. And the way you define functions in Python is with the def statement, the function definition. Looks like this. You have the name of the function, the arguments it takes, and then you can in the indented block you have the body of the function. So here you say what happens if you call it. So who's the first here? There's hello Sid. Right, so that's how a function works. Somebody asked before, what's the most common beginner issues? I find that the local variables in functions are not straightforward, which is why I'll not go into them. But the problem is, if you assign a variable in a function, it is local to that function, so it I used X somewhere else. So it won't show up outside of the function. If I use a function that I have said before, if I use a variable that I've said before in a function, that makes it the local variable. So these are two variables with the same name, and outside of the function I only see the global one. So this is I probably don't want to get too deep into this, but that's something to watch out for. It's really handy when you get into recursion, but otherwise it's a bit of a minefield. You have to this is the thing you have to think about when you learn Python. Or just don't use the same name outside and inside a function. Another question is, how do you ensure arguments to a function is of a certain type? And the answer is, don't do that. You can document it. You can say that this name should be a string by saying, this should be a string. If this returns the value, I can say this function returns a string. Right? So this is documentation. This is special syntax for documenting that this function expects to get strings. If I call the function with something else, there is no type checking. So the function is happily called. I get an error when I actually try to add together a string and a number. So these are just documentation. So there is no type checking in Python. You can do stuff like if and call the function is instance. And if that is not true, then you can, well, all you can do is raise an error. Which is basically the same thing that would happen in here. So this is something that people coming from languages where variables also always have types struggle with, and I really suggest if you try to learn Python, don't do this. Try not making sure that your variables are the right type. It's a bit of a different mindset, but it usually works. Usually works quite well. And if you want to be sure, then there is a third-party library called MyPy, which is a tool that goes through your Python files and ensures that all these declarations are enforced, or enforces that all these declarations are honored in all your Python files. So that's a third-party tool. It's a relatively new addition that helps if you have big teams and big code bases. But if you're just starting out, I recommend not worrying about the types and just going with the flow. It feels weird, but it works quite well. So no, there's no enforcement. What this allows you to do is write your own class that acts a bit like the string, and if it has this has these operations, it should be possible to use the function with whatever has the right operations. It doesn't have to be exactly the built-in string class. And yes, that means overloading, as you know it from C++, is not possible in Python. Well, it's possible, but we don't do it that way. You'd have to write a framework for that. And, usually you wouldn't do that. So I think I answered an earlier question on type annotations with that. These are type annotations, just documentation. You can also annotate variables inside the functions. I think the syntax is like that, just to help your type checker if you happen to run one. Right. So let's see. there's a bunch of other objects in Python. One I would like to show to you is the file object. So the way you open files is use the open function. Let's open this other module of mine. I can read all of the file and then close it. See? So this is the result of this read method, the contents of the file. A lot of the time people forget to close their files, so Python has a special command called with. It works like this. And the with command takes a block, and whatever object this returned, which would be an open file object, it assigns to this f. I can use it, and after you get out of the with block, the file gets closed. Or if it was a database connection, the connection gets closed. Or if it was any kind of other resource, it's dealt with at the end of the with block, depending on how that object is implemented. So this works the same. I could probably just print out the f here. That's some kind of open file object. And if you're making a library or using a library, it will have objects for or usually it'll have objects for the stuff you interact with, for database connections, for web requests and responses, for tables if you're doing data analysis, and so on. What makes Python quite nice is these well-defined operations you can do on objects. So you can iterate over some kind of container with the for loop. You can open and close resources with the with statement, and so on. Usually if you're defining some new class of objects, it's quite easy to give it these built-in kinds of operations, and then people generally will have a better idea of how to use the object. You know, if it's some kind of container, then you can iterate over it with the for loop. If it's some kind of resource that needs to be closed, use the with statement. If it's some kind of number, then probably plus and minus will work with it. And you can create your own objects that have these operations, but you can't define your own kinds of operations in Python. It's this limitation that I think makes it easy to use for the people who have to learn the library then. Right, is there anything I missed in the questions? There's this question. Can you go over the difference between decorators and annotations in Python? They're completely different things. Annotations are the type annotations here, just documentation about what you think the variable or argument or return type should be. Decorators are some modifications to a function that you can do. I will show you a decorator later. Let's do that. And a new question you used raised earlier, what kind of error handling mechanism does Python have? So it has exceptions, which means if you if you call if you do some kind of invalid operation, you will get this traceback, which means that if an error was raised by this statement here, somewhere here, adding a string to an integer, this function doesn't handle the exception, so the exception will bubble out of the function, and Python will say, okay, now at this statement, an exception happened. And if this was called by a function, or it was part of an import or so on, it would bubble up until it gets to the top level. And then you get this nice little traceback that tells you exactly where the error happened. You can also catch exceptions. There's a try except, and I would like to catch this type error and say something's wrong. Right, so if an error happens in here and it's a type error, then this gets executed. So that's how you handle errors. I see beginners a lot of times doing something like this. I don't recommend printing something's wrong, because then you lose the traceback and it's really hard to tell what exactly the error was. One of the misfeatures I think Python has is you can leave out the type error and just catch everything and lose information about your errors entirely and replace them by something you can't really act on. Right? So don't try to handle all the exceptions. It's not. I mean, it's if you're just doing some scripting, it's really much better to let Python show you the traceback. So I hope that answered the question. So I see I didn't set this up correctly. Let me reset this a bit. I set a custom prompt here just to make the command line shorter, and I realized I had something extra there. So this is what you would usually have in your command prompt and run Python. What I would like to tell you now is something about so-called virtual environments and installing libraries into Python. One way you can install libraries is...
Peter, I'm sorry to interrupt, but there is one question you missed. Can you explain how the self keyword is used?
Oh, okay. This will take us a few minutes. Right. So I don't know if I can paste it here, but one misconception about Python is that self is a keyword. Self is not a keyword. So just to get us... Actually, let me do one thing. I'm tired of running the demo.py over and over again. So I'll introduce you to a command that has nothing to do with Python. It's called entr. It's one of my favorite commands you have in Linux. I see some people giving the thumbs up. So what this does is it watches the file system for files you give it. So let's say I do ls and I feed all these files to entr and tell it to run Python 3 demo every time one of those files changes, right? And I also tell it to clear the screen. So now whenever I save the file, the code gets rerun. The Python 3 demo.py gets rerun. The command again is this. You pipe into it a list of files. you have it some options like clear the screen and the command to run, and it'll run automatically, right? So now I won't have to do so much work. I really recommend this file, even this command. It doesn't have anything to do with Python, but I hope you learned something new now. So back to Python. In Python you can create classes. Let's create a class for let's see, do I have a good example for classes? Point. How do you do absolute value of points? So what I'm doing here is creating a 2D point class with x and y coordinates that will have an ABS method. And how do you do the absolute value of a point? I think it's something like this. You take the x to the second power, y to the second power, and you take the square root of that. I will have to import the square root function, but let's get to that later. I can create a point, and the way you create, well, let me start a bit more gently. So this creates a class. A class is like a blueprint of objects you can have in your program. So this whole class statement is a description of how points will act. When I just define a class like that, doesn't mean I have any point in my program, just that I have the description. So nothing happens right now. I can print my class. Like everything else in Python, this is a first class object. I can put it in a variable and so on. So that's the class of points. To create a point instance, an object of type point, I call the class like this. And then I have a point object. Right? This is a object of class point from the main module. And it's at some memory location. This is just to tell several points apart. Okay, so what I can do is whenever I create my own object, I can freely set attributes on it. So I can say the x value and the y value will be like this, and then I can retrieve the attributes by the dot syntax. So I say object dot attribute, and whatever I saved on the object under this name, I can get back. And once I have x and y set on it, I can print my absolute value like that. I get the error that the function's square root is not defined, so I import it. And now I see the absolute value of my point. Usually when I do an import, I would stick it at the top of the file, just so that readers know what this module uses just from the top, and then I can use the square root wherever I wish, right? So what happens here, this is a bit of magic. This ABS is a method of point objects, and whenever I call it on a point object, this function gets called, and as the self argument, it will get the point or the object it was called on. So it's a bit like this in JavaScript or C, except in Python it just gets passed as the first argument to the function. Right? So I could use this p. I could name this p. It's the same thing. Python doesn't look at the name, but if you call it anything other than self, other people won't understand the code. So it's not a keyword, but it's a very very strong tradition to call this self. if you have some kind of nested classes and stuff like that, you can call it something else, but that's that. Now, of course, if I make a different point and get its absolute value, I'll get an error because I haven't set an x attribute on this object. Right? So this is an incomplete point. It's not useful. And yeah, Python is dynamic, and you can do stuff like this, and generally you will get a runtime error. This sort of means that Python is not that good for stuff like systems programming, when you need to make sure that every execution path of the program is correct, right? What Python is good for is prototyping, where you haven't thought everything through yet, but you're trying to make it work. You're trying to see whether your approach is right. You're trying to see what the program should do, and if there is something you haven't thought about, it's okay until you try to use it, and you can fill it in later. And then if you write your tests properly, it is very much possible to write robust programs in Python, but you don't have to. Right? It needs a bit more you need to be a bit more careful to write robust programs in Python. On the other hand, it's really easy to get started. It's usually faster if you have some kind of complex algorithm to write it in Python first, and then you can rewrite it in C or Rust once you know what the algorithm will do. And then you can worry about memory management and references and all that stuff that you don't have to worry about in here. That's also one of the questions that came before this stream was why is Python so popular for teaching programming? It's exactly because you don't have to understand and care about memory management, classes, functions, all of that at the very start. So you can start by writing programs, assigning to variables, and go through all these features step by step, and then actually learn a language that you can use in your day job and get paid for it, unlike some other languages that are used specifically for teaching, like Scratch or stuff like that. So that was a digression. Anyway, you can of course make it so that points always have x and y, and you do that by magic methods. They're officially called special methods. They have special names. You do underscore underscore, for example, initialization, and this method will take a self, an x and a y, and assign these attributes for you. And then every time you create a point, Python will call this method. So I have to give it these arguments, and you can see this print went perfectly well, and this call went badly because I didn't put the arguments in. So I didn't put it in x and y that Python would put in here. If I do that, now I have a point that will always be valid when you create it. And usually you would have methods like this, and there's even a shortcut where you don't have to write all of this by hand. But these special methods are something that Python uses to implement special behavior. For example, if I want to add 2 points together, I say this is my method called add, and it works by returning a new point with self.x plus other.x and self.y plus other.y, and then I can do hopefully p1 plus p2, pt plus p2, and I get a new object, and the x of that object should be 13, 12 plus 1, right? So this is how you can implement the plus operator in Python. You can implement conversion to strings in exactly the same way. Something like this. And then your point would be printed out nicely depending on what this function returns. You can see this is quite a mouthful or a fingerful to type. So this does this part of the string, then puts it the x attribute converted to a string, then adds another string that converts another number to string and adds it there, and ends with this one. There is a shortcut for this that I will not explain fully, but if you put an f before a string, that makes it a formatted string where you can put all of these things you can put into or that you want to format in these braces, and that works exactly the same way. Right, so this is a templating string, and all of these things are replaced by the value of the expression in them. So that's a nice way to do things like that. And lastly, all the built-in or most of the built-in functions like ABS check special methods. So you can actually call the built-in function ABS, and it'll delegate to the special method like that. So I can do that, and it works for my points. So I just spent almost half an hour on classes just to explain a bit more about this self thing. I hope that is most of the questions here. Yes. No new questions? So let me end this thing and talk about virtual environments and installing. Is there anybody I've lost at this point? I did go a bit fast, but it's you're not meant to learn this, it's just to show you what's possible. Right, I showed you there are these imports. You can import interesting stuff. Not everything is built into the language itself. Not everything is part of the standard library, like math is. Some stuff you do have to install. You can either do that by using your system package manager. Important stuff is usually part of your distribution. In Fedora, stuff is usually prefixed with this Python 3. You have a guideline for that where every Python library you're meant to import is prefixed with Python 3. On Debian or Ubuntu, I assume there's some similar convention going on. Maybe without the 3, or maybe without the prefix entirely. Should be easy to find out what that is. And once you install that, you can use it from your system. The other thing you can do is use the community or the Python community's package repository. So if I create a Python library that I want to share with the world, and I don't really have the power to package it for all the different Linux distros, I will uploaded to this website called pypi.org, which, if you're familiar with npm for JavaScript or cpan for Perl, it's a repository of Python packages. Anybody can claim a name and put a package in there. Let's see, somebody put here a package called Flask, which has this description. You can download it, you can see the source code link, and so on. And there is tooling where you can install this package on your computer. I'll get to that shortly. We have a question here. What are the usual errors when trying to run old Python 2 code with Python 3? So I have a nice terminal here where I can split it and then synchronize input. So this part is Python 2, this part is Python 3, all right? So one of the things that will probably get you is that in Python 3, print is a function, whereas in Python 2 it's a statement. So in Python 2 you can do something like this without parentheses, and people did that in Python 2 code. And in Python 3 that'll give you a syntax error because you need to put parentheses around the arguments to the function. The reason is the very beginning of Python, when the print function was first added, there was no way to make a variadic function that takes a variable number of arguments. So print needed to be a statement. Nowadays it can very well be a function. It's even better that it's a function because you can give it arguments like please print to a file, stuff like that, which was kind of awkward to do with a statement. So this is probably the most common message you will get if you're on Python 2 code with Python 3. The other error you will get is when combining byte strings and Unicode strings, which you cannot do in Python 3. They're completely different data types. So this will bite you in some of the more complex programs. Hope that answers the question. And now let us get to what I was trying to get earlier. So if you want packages from the community repository, I would recommend that you make a so-called virtual environment, which is a directory on your computer where you install these third-party libraries into, and you always need to activate this environment to take advantage of these libraries you installed. So my directory now looks like this. I can make a virtual environment, or venv. Python 3, that's a built-in library, and I will call my env. This will take a moment, and when it's done, I have a directory called env, which is my virtual environment. You can think of it as a project with a set of Python libraries that can be installed to it, and it's isolated from the rest of the system. So if I install a bunch of libraries in a bunch of different versions into this environment, I can delete this directory and get rid of all of them at once. I can create a new environment with a different set of libraries and different versions, and you know have different versions for different projects. It is not isolated as far as security is concerned. If you install some malicious library, as I said, anybody can create libraries. So if you install a malicious one, it can do bad stuff to your computer. But it's good practice to create these environments to isolate these third-party libraries that you install into your computer. So how do I activate this? I run source env bin activate. The name of the environment gets prepended to my bash prompt or other shell's prompt. And now if I run Python, it's from within my environment. And now everything I do with this Python affects this environment. One thing I can do is use pip, which is a Python library that installs other Python libraries, and I give it a name of a library on this community repository, this Flask, which happens to be a web server library. Once I have that installed, I can write a web server or web application. So let me pip install, install Flask, and it'll install Flask. It'll install all of its dependencies, and now in my Python code, let's get rid of all of this, I can import Flask, which I just installed, and I can do Python demo.py, and it imported successfully at least. So this is how you install a third-party library. You would do this if you're making a project, for example, that you want to distribute to different computers that don't all have the same distro, or if the library is not available to your distro. Right? So create a virtual environment, install a library. It's all nice, and if you get bored of it, just delete the directory with the virtual environment. That's one of the nicest things I find, that it doesn't install stuff globally into places I don't know about. So this Flask is one of the two most popular libraries for creating web applications in Python. The other one is called Django, like that. That's a bit harder to get started with, so I'll stick with Flask. And from the Flask, I will import a class called Flask. I will make a web application like this. This is actually something you will find in the Flask tutorial, so I won't really get over or go over what this does. It has a weird way of starting the application, which you will of course also find in the Flask documentation. You have to export an environment variable, then go Flask run, and it starts a web server at this address. And if I go to that address in my web browser, I see Flask is saying there's no web page there. This says debug mode off. I will, let's see if I don't know if it's Flask environment or Flask env. I hope I get it correctly. Right. So if you set the right Flask environment, it'll automatically reload, just like what I did with the enter before. So now I can iterate on my web application here and show you what this does. Right? I hope I haven't lost anybody at this point. So what I did is create a virtual environment, install a library in there, import the library into my code, and now I'm using it, creating a web application. So what I would like my web application to do is whenever somebody goes to my index page, I would like to show the string hello to them. And this is just a Python function. So when I refresh my browser now, nothing really happens. I have to somehow tell Flask to call this function when you visit some URL. And the way I do this is with decorators. And that's the reason I'm showing you Flask, because somebody asked about decorators. A decorator is a way to either modify what a function does or somehow register it to be called when something happens. In this case, I do app.route, which is a decorator from this Flask application, from this web application, that says whenever somebody visits this URL, the home page, call this function and return whatever the function returns. So I probably didn't get the reloader working correctly, but this is the result of my web application, right? Of course, I could do a lot more stuff with this Flask. You can build full-featured web apps with this. People have done that, but it's really easy to get started with. If you want to get into it, read that tutorial. It's quite nice. What I wanted to show you is this decorator, and what this does is it says to Flask, says to this app that at this URL, if a browser asks for this URL, run this function and show that. So we're getting some questions. Let's see questions. So the first one would be how to exit the virtual environment, and we activated this using nvin activate, and that sets up a bash function called deactivate, and that deactivates it. I think this is a bit of a misfeature. I prefer running a whole new bash process with the environment activating it, and then exiting that shell when I'm done. But this is like the canonical way people do it, and there's a variety of tools to automate this, to have a repository of environments and activate them easily and so on. But this is like the basic thing you can do there. And how do you update packages downloaded or installed by pip? You might have seen somewhere here I have an error or warning that I'm using an old pip and I should update it. So let me update a package called pip. So I would install pip packages with this, and I updated by putting update in here, right? So I would install pip, and with dash update, it'll update it to the newest version. What? Okay, read the man page. It's capital U. I thought it was dash update, but definitely it's dash capital U. So this will update pip from 19.3 to 20.1. A question: what is the difference between pyenv and venv? Ooh, I don't. I'm not sure if I know what pyenv is. Oh, So apparently there's a tool called pyenv. Oh, this is the one that will install different versions of Python for you. I have never actually used it because on my operating system I can actually install all the different versions of Python as system packages. But if your distro doesn't have that, then I guess you would use this pyenv tool to install different versions of the Python interpreter for you, as opposed to giving you these virtual environments, these sets of installed packages. Does that answer the question? So I see we have about 10 minutes, so I need to wrap this up. If anybody has a question for me, now would be a great time. Otherwise, there was one advanced question that...
Peter?
Yes?
I know you've been teaching like this. Is there any kind of training material place you would recommend people to go to dive into learning Python for bigger projects?
Oh, well, there's one I wrote, but it's in Czech, so I won't recommend that to you. So what I've been hearing good things about, and what was open sourced recently, is practical Python programming from Dave Beasley. I've heard a lot of good things about this course for a few years now, and it's been open sourced think less than a month ago. So if you already know a bit of programming, I would recommend this one. There's an official one on docs, python.org, the Python documentation, and this has a tutorial. That's also for people who know programming itself, or at least a bit, but it shows you all the features of the language in a friendly way. The rest of the documentation is the reference. It's a bit like man pages, very technical and complete. Ooh, lots of questions now. Could one install common math functions in an environment rather than importing? So the math module is actually part of Python standard library. So we always get that. And all the environments will share the standard library. And I think this question is a bit confused because there's installing and there's importing. So installing is that you take the files, take the modules, the files from the internet and put them on your disk so that Python can find them. So you do that once. Right? I have this environment, and now since I did this pip install Flask, that means Flask is installed in this virtual environment on disk. Whenever I activate the environment, Flask will be there. The other thing I do is importing, which is telling Python to read that file that I installed and to make it available in my program. Right? So installing and importing, you always have to do both. Install it on disk and then import it, read it from disk and execute or make the classes available and so on. I hope that answers some of that confusion. And another question, you imported individual functions. Can you import an entire library? Yes, I can. I actually did it here, so I imported all of math, and I can use math dot sign of some number. Pi. There it is. So I could do either from math import sign and then do just sign of that number, so this would be the variable I could use, or I could import the whole module, in which case I get a module math from this path on disk, and that has individual functions in it. I could also import everything, but don't do that. This gets really tricky if you then import stuff from a bunch of modules, then you don't know what variables coming from where. So sometimes you see this star for importing everything and putting it in your global namespace, but I recommend against it. So either of these options would be fine. I hope that answers the question.
Hey Peter, what's the delta between import math and import math? Oh, sorry, from math import star.
The difference is which object it makes available. So if you do import math, then you can use math, right? So you can do. So let's comment this out. So you can do math and math dot sign. So you have the object, the variable math available to you. You couldn't do
Also, you get
just sign because the variable sign is not defined, right? The from math import sign, that will give you this name, right? So these two are equivalent. It's just you get to this one through the module math. If you import the whole module, then you can access its functions like this. Does that make sense?
Yeah, I was more asking what's the difference between if you just do import math with nothing behind it, or from math import star. Are those two statements equivalent?
Pretty much, yes. It imports the whole module, and this one just gives you one piece of it. But the whole module is imported.
Thank you.
Can I, Peter, clarify that? If you do import math on its own, right, then I can access sign in the math namespace, right? But if I do from math import star, then all of the things that are available in math are now available without the math namespace.
Oh, yes.
Is that accurate?
Yes. If I do the star, which I don't want to talk about, then you have all the math methods available just like that. It makes a giant mess in the global namespace, but yes, the star means import everything, and in the next Python version where math grows a new function, you'll get one more function and something might break.
I've got another couple questions if I could take a shot.
Definitely.
This is awesome, so thanks a lot for doing this. I don't know if you follow our mailing list, but when this conversation kicked off, I didn't lurk in these things. But Peter, wrote a pretty good email about the differences between learning a language for the first time, right, learning to program versus learning a new language when you're learning how to program. And I don't know if you saw my camera's been messed up, but I had my two older boys in here. We're trying to transition them from like Scratch to Python. Are there anything you would recommend with Python to teach a programmer who has never programmed before? And then the other question I would have is a more self-serving, because I never live in it long enough to really know it. But I've started using like poetry and things like that over the last couple of years to wrap my virtual environments and requirements management. Is that something people do in real life? Because I have. And so I'm kind of curious about that as well.
Okay.
Your thoughts in general.
So the first question on beginner programmer resources, I actually personally have developed a free online course which I test by actually teaching it to live people. So I would not recommend that to you because it's written in Czech. So bunch of materials that that teaches you programming with Python from scratch. You just you have to know how to type on the keyboard and install stuff to your computer. Unfortunately, you can't understand it, so search the internet for this. I can't really help you. Sorry, I'm not a good person to do this. As far as poetry, so this goes into how to create these packages on the Python package index, which is a whole chapter to itself. Traditionally, it was done using a tool called Setup Tools, and for a long time that was the only tool you can use. Recently, in the past couple of years, and it's still going on, there's an effort to standardize how to create Python packages and standardize the file formats and the interfaces between the various tools in an effort to make it possible for other tools to exist and do something differently and better than Setup Tools did. One of those tools is Poetry. Another one that is coming up or that started doing this is Flit, which is more for pure Python stuff. And they're definitely viable. Definitely use them. They're actually the future because the old one, Setup Tools, has a lot of historical baggage and backwards compatibility concerns that make it not a very good choice if you're just starting with all this. On the other hand, it can do anything you could do. Anything that's possible in packaging, Setup Tools can do, but it's old and crafty. So if you're just starting out, Poetry would be a good choice, I hear. I've never actually used it myself, but that's what I would recommend learning right now. Right, I don't think I can take any more questions. There's 15 seconds remaining.
Well, thanks, Peter, for coming all this way virtually to talk to us here in Northern Virginia in the U.S. I feel very lucky that we found you to do this. You've been a very good resource in this. Is there anyone here who's got any more questions before we wrap up, or might not even be about Python?
I just have to say I really love Sean McGowan's shirt, and the fact that his son sat there for the vast majority of this meetup, and I saw him even asking questions, hoping they were relevant to the discussion. So watching your kids hang out and enjoy this was cool too.
Absolutely, I agree.
The other thing I want to say is anyone who is looking for a job or anyone who is looking to hire, go ahead and hang out on the meetup after this is over, and maybe we can, at least virtually get somebody a job.
Always looking.
Yeah. I probably won't hang out, but we're also hiring.
There you go.
Yeah.
I guess Peter can tell you all about that.
I have one of those somewhere.
Good job, Peter, with the very wide audience we have here. I found it very good. So thank you.
I hope everybody learned something new.
Sure did. Thank you very much. So I will stop the recording and the live streaming on YouTube. But
right.
As John said, just feel free to hang out if you have things you want to talk about.
So I actually